programming. And we have number 4, in-memory databases. These store data in the system RAM for faster access and processing. We have data-in-series databases. These optimized for storing and querying timestamps data. Then we are going to focus more on relational databases. As I said earlier, it is a type of database that organizes data into one or more tables, where each table consists of a row, and in row we talk about records, and it has columns, and this one emphasizes more on fields. The relationship between these tables are defined by the use of keys and constraints, making it possible to structure the query, then the data is structured manner. This structure allows for efficient data retrieval, manipulation, and management. Next, we are going to talk about the key features of a relational database. The first feature is tables. Under tables, we shall see columns and rows. Under a table, the fundamental unit of storage in a relational database, each table represents a specific entity or object and contains rows and columns. For a column, which is the same as record, each row represents a single unique entity in the table. Columns, each field represents a specific attribute or property of the records. Number 2 is a primary key. A unique identifier for each row in a table. It ensures that no two rows are identical within the table. Example, here we can take a table of employees and the employee ID. Where the employee ID could serve as a primary key. Then foreign key, a field in one table that references the primary key of another table. This creates a relationship between the two tables. For example, in a table of orders, the customer ID could be a foreign key that references the primary key of a customer table. Then we have relationships, the connection between tables that allow data to be linked and organized in a meaningful way. Under relationships, we have a one-to-one relationship. Each row in a table A has a corresponding row in table B. Example, employee and employee ID table. Employee ID. Employee ID has fields of employee ID, which is the primary key, and it has a unique number. In this scenario, each employee has a unique identifier, and each unique identifier is associated with only one employee. Here is how the table could look like. This one is having the employee ID. We have the first name, and we have 3 employees with employee IDs 1, 2, 3, with their first names being John, Jane, Alice, then their last name being Bell, Smith, Johnson, with email addresses as seen above, and they have phone numbers as seen in the table. Then we have employee ID table. Employee ID table has the employee ID and unique number as seen in the table. Explanation of the tables. We have the primary key. The employee ID field in both tables serves as the primary key, ensuring that each row is unique. Then we have one-to-one relationship. The employee ID field in the employee detail table is linked to the employee ID field in the employee ID table. Each employee has a unique employee ID, which is also associated with a unique number in that employee ID table. Then we have the ISQL command for creating tables. These are the commands to be used given the fact that I don't have the SQL app. I'm trying to write the SQL commands for creating the tables as seen above. That's how the SQL commands are. And if you insert these commands into the SQL app, you're able to create the tables using the app. Then we have a one-to-one relationship, a one-to-many relationship. A one-to-many relationship is a rational database in a rational database is a type of relationship where a single row in a table can be associated with multiple rows in a table B. But each row in table B is associated with only one row in table A. This is the most common type of relationship and is a fundamental to the structure of relational database. Example, we will create tables, one for customer details and another for orders. We have the first table as customer. The customer table has fields like customer ID, which is the primary key, first name, email, and phone number. The next table we have orders. The order table is having order ID, which is the primary key. It has a customer ID, which is a foreign key. It is being referenced from the customer table. It's also having the order date and the total amount. In this scenario, each customer can place multiple orders, but each order is associated with only one customer. This is how the tables may look like. Under the customer table, we have fields like customer ID, first name, last name, email, and phone number. The first customer ID is 1, his first name is John, the last name is Dio. Then it has the email address, which is johnneil@gmail.com. Then it has a phone number of 555-1234. The next customer is Jenny, last name is Smith, having email address of jensmith@gmail.com and has a phone number of 555678. Lastly, we have Alice, last name is Johnson, email is alicejohnson@gmail.com with a phone number of 558765. Then our order table, it's having order ID, customer ID, order date, and total amount. We see under the order table, we are seeing that the first customer with ID 1 is ordering more than once as shown in the table. So we have order ID, which is 1001, is customer ID 1, order date of 2003, October, then 1st. That is the total amount. Everything as shown in the table. I will not explain each detail, but that's how it is. Then if you go to the explanation of one-to-many, we see that the primary key, we have the customer ID field in the customer table and the order field in the orders table. These serve as primary keys and ensuring uniqueness within their specific tables. We also have the foreign key. Under that, we have the customer ID field in the orders table, which is the foreign key that references the customer ID field in the customer table. This establishes the one-to-many relationship between the customers and orders. A one-to-many relationship, each customer, which is a row in a customer table, can be a multiple order, rows in orders table, but each order, which is a row in the orders table, is associated with only one customer, which is the row in the customer table. Then we have the SQL command for creating the tables. For customer table, it's create table, customers, you open bracket, it's customer ID, you int the primary key, comma the first name, VAC 50, last name, VAC 50, email, VAC 100, phone number, voucher. When you're using voucher, it's to represent letters. Then we have the order table. You create the order table, you create the SQL command for creating the order table is create order tables, open bracket, you have order ID, you enter primary key. You have customer ID, you enter, then order date, which is supposed to be date. If you write date, you'll be able to get the content in the MySQL app. Then total amount, that should be in decimal. You consider the decimal, so it's supposed to be 10 by 2. Then foreign key, which is the customer ID to reference it. Then we have many-to-many relationship. A many-to-many relationship in a relational database is a type of relationship where multiple rows in a table A can be associated with multiple rows in table B and vice versa. This type of relationship requires a junction table, also known as a linking table or associate table, to properly represent the relationship between the two main tables. Example, we have the first table, which is the student table. It has fields like student ID, which is the primary key, first name, last name, email, and phone number. Table B, which is courses, it has the course ID, which is the primary key, course name, description, instructor name. Then we have the conjunction table, which is enrollment. Under enrollment, we have fields of enrollment ID, which is the primary key. We have a student ID, which is a foreign key, and a course ID, which is a foreign key. Yeah, these are the tables. We have a student table. It's having those fields and rows and columns as seen above. Then later, we have the course table, which is having those fields, and under the course table, we are able to see that, we are able to see the student IDs, their course name, the descriptions, and the instructor name. Then enrollment junction table, this is having enrollment ID, student ID, and course ID. Yeah. Then explanations for the table being created. We see that the primary key, the student ID field in the student table, then course ID field in the courses table. These serve as the primary keys, ensuring uniqueness within their respective tables. Then under foreign key, we have the student ID and the course fields in the enrollment table. Those are the foreign keys that reference the student ID and course ID fields in the student and course tables respectively. This establishes many-to-many relationship between students and courses. Then we have a junction table. The enrollment table acts as a junction table containing the foreign keys that link students to courses. This ensures that each enrollment record represents a specific instance of a student taking a course. These are the SQL commands. When you have the SQL app, you are able to insert in these SQL commands, and after inserting in these SQL commands, you're able to create a student table, courses table, and enrollment table as shown above. Then we have functions of databases that they help in storing data. Through the use of databases, there is efficiency in storing that amount of data. They also help in data retrieval. This helps to quickly access and retrieve data through queries. And data manipulation. Through updating and inserting and deleting of data, this can be done through data manipulation. We also have data security. We see that databases help to control access to data to ensure privacy and integrity. Lastly, we have data consistency. Database helps us to maintain the accuracy and consistency of data. Finally, we have the uses of databases. They are used in businesses, that is business application. Through businesses, they can help customers to manage their relationship, inventory, and financial transactions. They are used in e-commerce. Through this, storing product information, customer details, and transaction history are able to be maintained. Then we are also used in healthcare. Through databases, help in managing patients' records, treatment histories, and medical research data. They are also used in education, whereby they can store student information, course details, and academic performance data. Also used in database, social media. You see that databases are used in managing users' profiles, posts, and interactions. Databases are essential for managing and processing large volumes of data efficiently, making them a critical component of modern computing and information systems.